So last week we started initially with our motion graphs during our lab, and you were able to see kind of your results in real time once you graphed it. So we used a distance time graph with our lab. So because on our graph we had distance on the y-axis, time on the x, hopefully you put it in that way, you got a line, and I had you guys do it as a line of best fit. Now, in all reality, was it a perfect line of best fit? No. You guys actually noticed, you were like, hey, it kind of looks more like a curve than it does a straight line. And you're right. Because if it's a curve, what was happening to the car as it went down the ramp? Yeah, it was accelerating. Okay, so when I draw a straight line, though, like that, a linear line, what does that tell me about the slope at every single point on that line? It's the same. Good job. Okay, so if my slope is 1 right here, my slope is still 1 here, 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 here. Well, because our slope is our rise over our run, that gave us distance over time, which was speed. So if I have a linear line like this, that means that my speed is yes, it is a constant speed. But more importantly, I can put this in terms of velocity by saying, what kind of slope is that? Positive, negative, or 0? Positive. So I can say that this is a positive 1 meters per second, which just means I started here at position 0 and I walked to 10 meters. That means I walked in a straight line. Okay? So I went away from start. So if I have a positive slope, I'm going away from start. If I have a negative slope, what do you think that means? Does it mean I'm slowing down? No, it just means I have a negative velocity, which means I'm walking at a speed, but in what direction? Yeah, the opposite way, the negative direction, which in this one, it would be back towards start. So it's still a constant speed if we got a linear line. The red line maybe is a negative 1 meters per second, and that means I'm going back towards start, or whatever I denote as the negative direction, which could be down, it could be south, or it could be to the left, depending upon what you set as your positive and negative values. So if you take a look at this graph, look at A and B. Both of them have what kind of slope? Yeah. And take a look. This one is a position time graph. So a change in my position over time. My slope here is my what? Velocity. So A, I have a positive velocity, which means I'm moving towards or away from start? Away from start. Now, isn't that the same for B as well? Yeah, but what's the difference between A and B?
A is going faster.
Yes, so A is going faster, whereas B is going slower. All right, both A and B started at what position? 0. Who made it further, though?
A.
Good. Okay, so do you see how the questions you're going to get are just basic reading the graph? But you've got to have those skills and feeling comfortable with reading graphs, and that sometimes is difficult for people. Okay? Take a look at C. Read the graph, look a little bit closer, ask yourself, what does that mean? What do you guys think for C, that horizontal line?
That means it's not changing position. It started at 6 and it's
Perfect. So we know that here, the slope of this line is what? Slope of a horizontal line is 0. So if my velocity is 0, remember there's different ways my velocity could be 0. I could have come back to start, or I could just not change my position. In this one, I started at 6, I'm still at 6, and I'm at the end still at 6. So on this one, when I have a horizontal line, I'm stopped. Okay, look at D. What position did D start at?
Start at 12 and it went
12.
0.
Yeah, so I have a negative velocity because I'm not moving away from start, I'm moving
Towards it.
towards start. Okay. Now, is that still a constant speed?
Yeah.
Yeah.
Just going the opposite way.
Technically, aren't all these constant speeds?
Yeah.
Yeah. What kind of line would I need for it to not be constant?
Oh, well,
What kind of line is that?
I don't remember for some reason. I'm a math guy, but I don't remember.
Oh, what did I just draw? What is this?
It's gonna come back to me
No.
as exponential.
Sure, you're getting technical. A curved line. So if I see a curved line, are they going at a constant speed or do I have an acceleration?
Deceleration.
And this one, since it's moving up, is a positive acceleration. Okay. Take a look here. My y-intercept, what does my y-intercept tell me then?
It tells you where you started.
Yes, that's where you're starting, your starting point. If I have a positive slope, I'm moving.
Away.
Good. If I have a negative, good. No slope or a horizontal line.
0.
What's 0 though?
The
Velocity, so I am stopped. Good. The steepness of the line, the steeper it is, the faster. So it's how fast, oopsies, we'll go fast or slow you are going. Okay? All right, so take a look at this one, the position time graph. Look at position 1. Where did my runner start? 0. And they moved away from start for how many seconds? Can you see that? I know it's kind of blurry up there. 10 seconds. How much ground did they cover? 8 meters. So I rose 8 and I ran 10. So my slope is a positive 0.8 meters per second. What did my runner do from time 10 to time, looks like about 20? What was my velocity here at 2? 0. They stopped, right?
Yeah.
And then what did they do from at position 3, from here?
They came back.
Yeah, we have a negative velocity and they went back to start. What did they do at 4?
They stayed constant, or they stayed at 0.
They stopped. You got to be careful saying just going constant versus being stopped. And then at 5, they moved away from start, but at a velocity that was greater than my position 1. So I could solve for that velocity as well just by doing slope. Okay, just by rise over run. You could do it that during this interval. How much did I rise? How much did I run? And I'd get my velocity. Okay. All right, so position time again. Which color are they stopped?
Green.
Which one are they moving away from start of positive direction? Red and purple, right. But which one's moving at a constant speed?
Red.
Red. Who's going away from start with an acceleration?
That's purple.
Purple. How about towards start with an acceleration?
That's black.
Black. Towards start with
Cyan.
constant speed? Blue. Good. All right, so those are position times. You guys practiced then going from position time to a velocity time on your gizmo, okay? Velocity time is going to be set up a little bit different, okay? On this one, we are going to have our velocity on our y and our time on our x. So what is a change in my velocity over time? I'm looking at slope now. It's a change in velocity over time. Yeah, this now is going to represent my acceleration, okay? Please be careful. These don't say anything about your location or your distance, only the velocity at which you are traveling, okay? So look here. At time 0, how fast are they moving? Good, 200 centimeters per second. Here, how fast are they going? Okay, so that means they're traveling at a constant positive velocity, right? Because it's greater than 0. So on that one, did they accelerate? No. This is where it gets really difficult and where people make mistakes are because on the last type of graph, position time, a horizontal line would have meant that they are stopped, right? Whereas here, this is where you got to be careful. Say, okay, well, my velocity, what is it here? What is it here? Versus the last one, it was what's my position? What's my position? Okay, so take it slow at first till you take a look at a couple graphs to these graphs. All right, look here. Say this is positive 10. That means I have a positive 10 meters per second velocity. All of a sudden now I have negative 10 meters per second down here. So that means what happened right here? There was an acceleration, right? And I went from a positive 10 to negative 10 meters per second. And so if it's over a period of time, I could divide that by my time in order to calculate my acceleration. Another way that I could look at this, still look on my y-axis, I have velocity. On my x-axis, I got time. So look here. I start at what velocity? 0. And I finish here at what velocity? So I increase my velocity by 8 meters per second in how many seconds? So what's my acceleration? Positive 2 meters per second squared, or meters per second, either counts. Okay, so that means for the first 4 seconds they were accelerating. Then they reached their top speed of 8 meters per second. And then look, 8 meters per second, 8 meters per second, 8 meters per second, 8 meters per second. So what is happening here? Acceleration equals, what's my slope equal to, guys? 0. So at that point, I'm going at a constant speed. Okay? So I'd be going at a constant speed. All right, so take a look here. Which line? So on these, you typically see the x-axis set up like this, where you have time on the x, and then on the y, you actually will have a positive velocity up top, negative velocity down below, and then 0 in the middle. Okay? So look at the green line. The green line, they are going at what? Constant positive velocity. Red line, constant negative velocity. So on those ones, A equals 0. Good. All right. What about yellow line? Let's start here. Yellow line going up. That is a positive acceleration. Look at my blue line right here. Okay, that's a negative acceleration, but then eventually I get to 0, and then I increase my velocity, but I increase my velocity in the negative direction. So even though the speed's going up, I'm accelerating in the negative direction. Okay? If I have a curved line, am I accelerating at a constant rate? No, so that's where those curved lines come in. Okay? So take a look here. From 0 to 20 seconds, I have a positive slope, which means I have a positive acceleration. Horizontal line means that I have a constant speed. My acceleration equals 0. The green line right there that I just highlighted for you, negative slope, negative acceleration. And that means they're accelerating, so they're pushing on the gas at a constant rate. When you have something like this at the end, the blue at the end, you see that? That means I'm going to push on the brake some, and then harder, and then harder, and then harder, and keep going so it accelerates faster and faster and faster and faster. So the acceleration would not be constant for that time period. But no matter what, my velocity is increasing there at the end. And I could look at my velocity by coming to the left on my y-axis. All right, so again, if I have a positive slope, I have a positive acceleration. If I have a negative slope, I have a negative acceleration. No slope or a horizontal line, acceleration equals 0. I'm traveling at a constant speed. Okay? That is the hardest thing for you guys to be able to do, is keep those straight. You really got to look at it and say, between these 2 points, what is happening? Okay? So you got to be able to describe what each of those lines mean. So I really suggest going back, re-watching this, or taking a little bit more time on your gizmo and looking at how that person moves on the bottom. The nice thing is you have a person moving, and then you can see what happens on position time and velocity time. Okay? Alrighty, guys.